Alright, we're going to take a look at lesson 8.4, angles of elevation and depression. In lesson 8.4, we're going to use the trig that we learned in 8.3, the sine, cosine, and tangent functions. And what these are going to be application type problems. So let's take a look here at what it means to be angles of elevation and depression. Now, first of all, we're looking at the angles of elevation. Angle of elevation is the angle between the line of sight and the horizontal when an observer looks upward. Everything has to do with the horizontal. You're always going to look out in the horizontal first. You're looking, basically, think of it this way. You're looking straight ahead, and then you're going to look up at something. That is, from your eyes to whatever you're looking at is called the line of sight. So the angle of elevation or depression, whatever it may be, always goes from the horizontal to the line of sight. So if you're looking up, it's an elevation. If it's looking down onto something, it's a depression. So if you have a pilot up here looking out front to the horizontal and then looking down to something on the ground, that is his line of sight. Therefore, this is the angle of depression. So it's the angle between the line of sight and the horizontal when an observer looks downward. So in the first example, we are going to be comparing our different angles of elevation and depression. So the first thing we're going to do is we're going to write down what each type of angles are, if they're angle of elevation and depression. Then we're going to kind of describe a little bit about what they're looking from what to what. So if you look at angle 1, if you see the dotted lines, those represent the horizontals. The solid line is the line of sight. So angle 1, you're looking here, starting at the horizontal. This is a bird. We're going to call this the observer or the man, and then we have, this is the top of the mountain and of course the base of the mountain. So the observer is looking out across here and he's looking down, the bird is looking down to the observer. So this would be an angle of depression. So we're going to just abbreviate here. Well, I say that, we'll abbreviate for the next ones. Angle of depression, and this is from the bird to the observer or the man. Okay, this is from the bird to the man. Now angle 4 is down here. This is the horizontal. So this is the line of sight. So you're going to have to draw a line up to the line of sight. So this is going to be an angle of elevation. Now what is the angle of elevation from? Well, it's an angle of elevation from the base of the mountain, so the base of the hill, we'll call it a hill, to the observer or the man. So from the base to the man, he's looking up here. Angle 2, this is going to be an angle of going from the horizontal to the line of sight. This is an elevation, you're looking up. So elevation from the man to the bird. Then we have angle 3. Angle 3 is the man looking out front and then looking down to the base of the hill. So this is going to be a depression problem, and it's going to go from the man to base of the hill. Now, what I want you to notice here is that if horizontal, this is the horizontal, and they're all going to be horizontal, so they're all parallel. So, if you notice here that if these two lines are parallel, then angle 1 and angle 2 are alternate interior angles. And what we remember from alternate interior angles and parallel lines is that they are congruent. So the angle of depression from the bird to the man is the same angle of elevation from the man to the bird, and vice versa for angle 3 and 4. 3 and 4 are alternate interior angles, so therefore they're congruent. So this is the angle of depression from the man to the base of the hill, and from the base of the hill to the man, these two angles are going to be congruent. That'll come into play in here in just a minute. So let's take a look at example 2a. Suppose you stand 53 feet from a wind farm farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is about 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? Now what they've done is they've drawn a picture here. So what we're looking for, x is the distance from here to here. Okay, this angle, this triangle right here, right triangle, can only be made to find this distance right here. But what we're looking for is we're looking for the entire distance. That means we're going to have to find the distance going from here all the way down to the ground down here, and that distance in between. So if we take a line here and draw this distance right here is the distance we're looking for. So I'm going to call that D. Now how do we find D? Well, if we set up our trig, a right triangle trig, we can find the value of x because we know how far this person is from the base of the turbine. We know the angle of his eyes, but that only gives us here. Now what they also gave us, the information they gave us, is that from here to here is 5.5 feet, which means we're going to need to add this on to our final value of x. So the distance D is going to be found by taking whatever we get for x plus 5.5 feet. Now, what are we going to use to find x? Well, we have our right triangle, just so we can mark on a little bit better. I'll draw your right triangle here. This is our 56.5 degrees. We have this distance is 53 feet. And we're looking for x. So which trig function uses the opposite side from the angle? This is our reference angle, opposite side and the adjacent side. There's no hypotenuse, so that means that this is going to be tangent. So we're going to take the tangent of 56.5 degrees and set it equal to x over 53. The opposite side goes on top, the adjacent leg goes on bottom. Once again, we're going to make it into a proportion by putting it over 1 and cross multiplying. 1 times x is x, and then we get 53 times the tangent of 56.5 degrees. So now we'll take out our calculator and we will take a look and see that what that measure is. So 53 tangent 56.5 equals 80.07. So we're going to say this is about 80.1 feet. We'll just leave it 0.7 for right now. We'll round it off in a minute. So we get 0.74, so we'll get 80.07. Now, to find our distance D, we're going to take the 80.07 and we're going to add the 5.5 feet on. So now we'll go back to our calculator. We'll take this, add 5.5 feet. That gives us 85.57 feet, and it says we're going to round approximately how tall is it? Well, we're going to go to the nearest foot, which means this is going to be approximately 86 feet. So the distance is about 86 feet tall. So once again, we're using our right triangle trig to help find missing values. In this case, we had to use our trig and then add in the height of the man's eyes. All right, so let's go look at our next one. You sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is about 6 feet above the ground, and you are about 1,000 feet from the base of the cliff. What is the approximate height of the rock climber to the ground? So, first thing you need to do is, if they didn't give you a picture, you need to draw a picture. So we're going to start off by drawing the ground. So we'll have the ground here. Now the ground is going to be considered to be a horizontal line. Now I'm going to draw what we have is the height of the cliff here. So we're going to draw the cliff here. And then we'll just make this cliff a little bit more realistic here. Now we're going to have to put a person up here climbing on the cliff. So we see somebody climbing right here, hanging on. And then we have our person down here. These must be aliens because they're all green. Now his feet don't touch the ground. Now they do. Now, so what we've got here is we have this guy looking up, and we're trying to see their line of sight. So draw the line of sight from here to him. So we want to know, how high is he off the ground? Well, the next thing we're going to do is we're going to draw our right triangle. So we're going to draw our horizontal, and then we have it's perpendicular with the side of the mountain. So what we know is we know that we're 1,000 feet away from the cliff. We know that my eyesight is about 6 feet. So from here to here, we're looking at 6 feet. And we know that it's about a 32-degree angle to this person. So we want to know, what is the distance? How high is this guy from here all the way down to here? Our distance D. So make sure you've drawn it correctly. Now, set up use your trig functions to help find the distance of D. So pause the video, work it out, and come back and see how you did. All right, so let's look here. We're using the tangent function because we do not have the hypotenuse. So we have the opposite and the adjacent, so this is going to be using tangent. So we have the tangent of 32 is equal to x over 1,000, opposite over adjacent, cross multiply 1,000 times tangent 32. Let's go over here and put 1,000, tangent 32 degrees. And since we're rounding this whole number here, we're going to be 624.8 is about 625 feet, so x about 625. Now we're going to add that to the 6 feet, and that's going to give us the distance the climber is from the ground is approximately 631 feet. All right, let's move on to the next one.